So today what we're going to do is proving similarity of triangles. Now we said in the last video that if I have a triangle like this one, and then I make a copy of it and make it a little bit bigger, okay, these two triangles are what we call similar. Okay, they're exactly the same triangle, just one is bigger than the other. Now, what this means when you have similar triangles is that the angles in those triangles are all the same. So this angle here will be the same as this angle here. Okay, this angle here will be the same as this angle here. And this angle here will be the same as this angle here. And we can use this in order to prove similarity. So if we know that two triangles have two angles that are the same, we can therefore say, yes, they are similar. Okay, now that's what you're going to learn to do today. The first thing is that in these triangles here, we've got them marked, okay? And all the ones you're going to get in the beginning will just have it marked, okay? But later on, you will have to show that two triangles are similar. So you are going to have to prove it. Now, why do I say that you only need to prove that two are the same? If we say that this one is, for example, 30 degrees, and we say that this one here is 40 degrees, okay? And let's say that in the other triangle we knew that this one was also 30 degrees and this one was 40, then there is only one possible answer for that third angle, okay? The third angle, angle C in the first triangle, must be 110 degrees, okay? You can see my diagram's not very accurate. And in the second triangle, you must also have 110 degrees, okay? So if you can show that two angles are the same, then you can automatically say, yes, these two triangles are similar. Okay, you don't have to prove the third one. So what we're going to do is we're going to show how to write this. Now, in this example, we've put the colored dots in there, okay? That is an example of, where it's given to you, okay? It's important with geometry. We have told you in the past that you always write a reason for any statements that you make. And this is really important in this chapter. So if you make a statement, you must give a geometrical reason why. So for example, in this one, we could say angle A is the same as angle D. Okay, and actually, I'm going to erase that because I like to be a bit more clear about what angle A is, because angle A, in this case, is very clear. We only have one angle A. But in some triangles, you might have different lines going all over the place. So this is this angle here. So we're going along this line and across here. Therefore, we're talking about angle CAB. Okay, so this is angle CAB. I'm just going to get rid of all that color again. Okay, and angle CAB is the same as, in the other triangle, we're talking about angle FDE in order of the letters that you go through. So it's the same as angle FDE, and because we gave it to you, we said what it was with the little colored dot, our reason for this one is that it was given. Okay, so if it's stated in the question or it's written on the picture, then you can say that was given. So CAB is equal to FDE, and that was given. We can say also angle, we're going to say B is the same. So angle CAB or ABC is equal to angle FED, and that was also given. Now, we have shown that two angles are the same. So what I like to actually do is write an A here and an A here, and that comes up with more significance later. So we can now say, therefore, these three dots mean therefore triangle ABC is similar to triangle. And when you do this, you must reference the same letter. Okay, so A was the blue angle. Okay, the blue angle in the second triangle is D. All right, so what we're going to write here is D. B was the red angle. So B we had here as red, and red in the second triangle is E. So we put E second, and C was green here, and that is F in the other triangle. So you need to get these in the same order. So triangle ABC is similar to, that's what that funny wave means. This means is similar to triangle DEF. And as a result of that, we can now find information about these triangles. Now, I would like to do one with you guys that's maybe a little bit less obvious, just for something interesting, and also where we're going to find a missing side. Okay, so what we're going to do now is an example with a triangle like so. Okay, this will be A, B, C, D, E. Okay, I would like to say that AE is 8, BD is 5. We'll say BC is 6, and I want to know what AB is. AB is going to be X. Okay, now when you get a question like this and you need to find what X is, the first thing you always need to do is one of these similar triangle proofs. Okay, this is a similar triangle proof. And you must do this anytime that you need to use the ratio table. Okay, if you do a ratio table without a proof, then you haven't shown anything. Okay, you get 0 points. But you must do a proof to show that these two triangles are similar first. So, what can we see that is the same in these two triangles? Firstly, what are our two triangles? You can see that our two triangles, the first one is like this. Triangle ACE, that's one triangle. Okay, so we're looking at triangle ACE. The second triangle, in this case, is going to be triangle CDB. Okay, there's just a little mini version of that one. So our two triangles, and sometimes it helps to write that somewhere, triangle ACE and triangle BCD. And that's just so that you remember what you're looking for here. So we want to prove that these are similar. We're looking for angles that are the same. Hopefully you can already see that we have here 90 degrees. Okay, so straight away we can say angle EAC, and make sure you go all the way to C because that's the triangle. The triangle doesn't stop at B, it goes all the way. So this is angle EAC is equal to angle DBC. Okay, why do we know that? We know that because it's 90 degrees. So we can say 90 degrees, comma, and that was given to us. All right, later on you're going to learn other ways of this. There are a few rules and things that we'll talk about, but that comes later. So that's the first one. And I like to color the corners as I go. If you know that two angles are the same, color them in, because it really helps with remembering later what order to write the sides in, especially when you use your ratio tables. Okay, so that's our first corner, or our first angle. Sorry, I should use the proper terminology. What other angle is the same in these two triangles? We have ACE, this big one, and we have BCD. Now, hopefully you heard it when I read them out. Both of these triangles have angle C in them. Okay, angle C is this angle here. Okay, and this is in both triangles. And you can see that it takes the exact same shape in both triangles. Okay, it's not that one is a C where a line goes up here. So you do have to be careful of that. So angle C is the same in both. We can say angle AC, and remember, use the whole thing. So it's going to be ACE is equal to angle BCD. Now, in this case, what's our reason? Why do we know that this angle is the same? It's because it's the same in both. So what reason we normally use here is called shared. Okay, it's a shared angle. Okay, we have now proven A and A, angle. So we can say, therefore, triangle ACE is similar to, and this is where we're going to have to check, A was the green angle, and in the smaller triangle, In the small triangle, the green angle is B. So we're going to put B first. C is the purple, and that's the same for both, so we know C goes next. And then the empty angle in both is E in the big one and D in the smaller one. Okay, so we have now proven similarity. This was our proof. So our proof is here. Following on from that proof, we can now use this information to find what the length of AB is. Okay, now let's do this. We're going to make firstly a ratio table. In our ratio table, we need to write our two triangles in. This is one thing that people find quite hard the first few times. Once you get used to it, it's okay though. So we need to look at our first triangle. Our first triangle was ACE. So the side lengths in that triangle were AC, CE, and AE. So now we want to look at what the equivalent of those sides were in the smaller one. And this is again where the colors help. AC was green to purple. In the small triangle, green to purple is BC. So we're going to put that underneath. The next one was CE, so purple to empty in the big triangle. In the small triangle, purple to empty means CD. And AE is green to empty in the big triangle. And in the small triangle, that is BD. So as I said, it really helps to color your angles as you go, even if you don't need to, because it really helps when you do this stage. Also with writing out your similarity statement. Okay, so now we can fill in what we know. So we know AE is 8. So where do we put that? Over here by AE. We know that BD is 5. Fantastic. CE we don't know, so we're not going to put anything in there. CD we don't know, also going to leave it empty. And the reason is I know we don't need them for this one. AC, you can see here, is x plus 6. Okay, the whole way along is x plus 6. And BC is just 6. So now we have a ratio table and we can cross multiply in order to calculate what we want. So if we cross multiply, we have 5 brackets, x plus 6 is equal to 6 times 8. So 5x plus 30 is equal to 48. You could also start by dividing by 5, but I find this a bit easier. Now that we've done this, we can say 5x is equal to 48 minus 30, which is 18. And x is equal to 18 over 5. In this case, it's a distance, so I probably would convert that. So we have 5 3s are 15, and there's 3 left, so 3 and 3/5. Okay, and then we found x. So this is how we prove similarity in a triangle, and this is how we calculate a missing side. It doesn't change a huge amount at the moment. They will obviously get a lot harder, but this is a good starting point for you. And as we go further in, we're going to start looking at different rules that you can use for why we have proven this similarity. So that's the next stage. In the next lesson, we'll be looking a bit more at the different rules you can use. At the moment, given and shared is all you need. And shared is sometimes hard for people to see, so that's one to pay good attention to. But in the future lessons, we'll start looking at other things that you can use, other rules that you can use in order to show this similarity. Okay, enjoy.